Most LLM document systems are good at retrieval, but they're not as good at preserving understanding over time. That is a core problem behind LLM Wiki. This is not a new model architecture, or it is not a new retrieval algorithm. Instead, it is a knowledge workflow pattern. The idea is very simple. Instead of making the LLM rediscover the same synthesis from raw documents every time, use the LLM to build and maintain a persistent knowledge layer. From first principles, when you use LLMs with documents, there are four core problems. One is storage, retrieval, synthesis, and persistence. Most systems handle storage and retrieval reasonably well. The weakness is in synthesis and persistence. Most systems can retrieve relevant text, but they usually do not retain the understanding that was built from the text. So when you ask a deeper follow-up question, the model often has to retrieve, reread, reconnect, and resynthesize again. That repeated work is the inefficiency. The default RAG pattern is straightforward. It stores raw documents, chunk them, create embeddings, retrieve relevant chunks at query time, and answer from retrieved context. That is optimized for finding the right raw evidence quickly, and for many use cases that is more than sufficient. But it becomes inefficient when the work is iterative, cross-document, synthesis-heavy, and recurring. Let's try to understand this with an example. Consider you're reading 10 papers on the topic, comparing multiple approaches, tracking how ideas change across sources, doing due diligence over several reports. In those cases, the system keeps recomputing similar understanding. RAG retrieves information well. It usually does not accumulate understanding as a durable artifact. What LLM Wiki changes? LLM Wiki changes when the LLM does the cognitive work. Instead of doing most of the synthesis only at query time, the LLM also does synthesis during knowledge building time. If you look at the pattern of LLM Wiki is, raw documents remain the source of truth. The LLM reads them. The LLM creates and updates a wiki of markdown pages. Those pages store concepts, summaries, entities, comparisons, and links. Feature queries use that wiki as the main context layer. So the important shift is this. RAG stores chunks, LLM Wiki stores accumulated understanding. That is a key distinction. LLM Wiki is useful when the work is bounded, recurring, synthesis heavy, and evolves over time. A simple example is research. Say you are studying transformers and you have the original attention paper, scaling law papers, retrieval papers, context compression papers, agent and benchmark papers. A plain RAG system can answer questions from these papers. But every time when you ask a question like, how did the idea evolve? Where do these papers connect? Where do they disagree? And what changed over time? The model keeps reading the synthesis again and again. With LLM Wiki, that synthesis becomes persistent. Now you can have a page on transformer evolution, a page on context compression, a page on comparing retrieval versus compression, and a page on scaling laws. Pages linking specific papers to broader themes. That is where the pattern becomes valuable. When we look at the LLM Wiki architecture, it is simple and can be understood in three layers. The first layer is raw sources. These are the original documents, papers, reports, notes, transcripts, articles, images, or data files. They remain immutable and are the source of the truth. The second layer is wiki layer. This is the maintained markdown layer. The typical pages include topic pages, concept pages, entity pages, summaries, comparisons, synthesis, contradiction notes, investigation notes. This sits between the user and the raw corpus. The third layer is the schema or instruction file. This is usually a markdown file like cloud.md or agents.md, and it defines page structure, naming conventions, ingestion behavior, query behavior, maintenance rules, index and log conventions. This is what keeps the wiki consistent over time. If you look at the end-to-end flow, the step 1 ingestion, a new source is added, the agent reads it, extracts key ideas, identifies affected pages, creates new pages if needed, it updates the index and appends to the log. And Karpathy also mentioned that one source may touch around 10 to 15 pages. The second step is query. The user asks a question. The agent first consults the wiki, index, summaries, concept pages, comparison pages, linked pages, then it answers. If the answer is valuable, it can be stored back into the wiki as a new artifact. Step 3 is lint or maintenance. The agent periodically checks for contradiction, stale claims, orphan pages, missing concept pages, weak crosslinks, knowledge gaps. So the full operating loop is ingestion, synthesize, query, write back, and maintain. That is the real system behavior. If you look at the important support files, the LLM Wiki consists of two important support files. One is index.mb. This is the catalog of the wiki. It gives the agent a map of what knowledge already exists and where to navigate. And Andrej Karpathy says this simple index-first approach can work surprisingly well at moderate scale, around 100 sources and hundreds of pages. The second file is log.md. This is the chronological memory. It tracks ingests, queries, updates, maintenance passes, evaluation over time. This gives the system temporal continuity. The hardest part of a knowledge system is not storing documents. It is not even retrieving them. It is bookkeeping, updating summaries, maintaining links, adding missing pages, keeping structure coherent, tracking contradictions, keeping the knowledge base current. Humans are usually inconsistent at that. LLMs are relatively good at repetitive, structured maintenance work. That is why this pattern works. The real idea is not markdown wiki. The real idea is use the LLM as a knowledge maintainer, not only a question answering layer. Now we come to the limits. The first challenge that we see is scale. A flat markdown wiki with a single big index is not a scalable primary architecture for very large corpora. Karpathy explicitly says that the simple approach works at moderate scale and suggests adding proper search over markdown as the wiki grows. The second challenge is drift. The wiki is a derived artifact. That means it can overcompress, lose nuance, reflect flawed summaries, drift from raw source of truth. That is why raw documents must remain the source of truth underneath. The third challenge is maintenance fanout. At small scale, updating many pages is manageable. At a larger scale, one new source can affect too many pages. That means eventually you need prioritization, scope maintenance, selective refresh, better search or navigation. If you look at the comparison between RAG and LLM Wiki, RAG asks how do I retrieve the right text quickly. LLM Wiki asks how do I stop the system from rediscovering the same understanding repeatedly. RAG parses chunks, embeddings, indexes. LLM Wiki parses summaries, concepts, entities, comparisons, maintained understanding. RAG is strongest for broad retrieval. LLM Wiki is strongest for bounded, evolving, synthesis-heavy work. So what is LLM Wiki really is? It is not a magical model, or it is not a giant enterprise platform. It is a simple but useful system pattern. Use the LLM not only to answer questions, but to continuously maintain a persistent knowledge artifact. Once you do that, you are no longer just storing documents, you are storing understanding. And that is why the idea matters.